to Tech Tuesday. My name is Tom Levine, Cornerstone's technical and commission specialist, and today we're going to be talking about something a little bit less straightforward to everyone than maybe it should be. This is how to set up your own home internet, and there are a few different reasons that you'd want to do that, actually. You'd want to buy your own equipment and set it up yourself versus having like Spectrum or Cincinnati Bell come in and do it for you. We're going to get into that here in a second, but first, some general housekeeping. If you have a question, please type it in the question box or in the text chat. I will get to it by the end of the presentation, I promise. But if it's, maybe detracting from what I'm trying to say at that moment, maybe I'll wait until the end. Either way, I promise I will address your questions, and I'm more than happy to answer anything you could possibly ask. So let's go ahead and see the next item. That would be connecting. So in order, if you have a question that you don't want to ask in the presentation, feel free to email me directly. That's tlevine@crnstone.com, or call me at 513-487-5390. We will be showing this again at the end of the presentation. So if you feel like you have to rush and jot it down, please don't. I'll have it displayed at the end as well. Also, I'd want to mention that we're actually launching Cornerstone's new and improved AGB portal here soon. That will be on the 15th of June. This will be for all broker partners as your one-stop shop for managing your book of business through Cornerstone, from carriers, client information, and commission schedules. If you have any questions about the new platform and your access, please reach out to your broker advisor or to the AGB support team. I'll be putting up a link to them here in a minute, but that one displayed in our slide right now is also correct. It's www.crnstone.com/AGB. And last but not least, our cash incentive program. You could earn up to $7,000 with Cornerstone's cash incentive program. The more you sell, the more you earn. For all group and individual new business sales between January 1st of this year, 2022, and December 31st of 2022, you earn points that bring you closer to a $7,000 cash prize. If you would like to learn more about that, we have more information on our website as well. So, that being said, networks and your Wi-Fi. What do those two things have in common? Well, they're kind of the same thing. One thing to note is that there are a lot of computer terms that industry professionals use that really don't need to be that technical. But you do need to know these two in order to help get more familiar with setting up your home Wi-Fi. The first is local area connection, and the second is wide area connection. The reason we're getting into this is that all Wi-Fi really is a part of your wireless network, which is the connections of a lot of devices that bring you the internet. Your local area connection is all of the sort of network that you have in your home or maybe in a business. It's a bunch of devices that are communicating within the same set of interconnected routers, which in layman's terms just means local. LAN, or LAN, stands for local area network, and it's all of the devices connected on the circuit in your home. It is the level before the WAN or WAN connection. A WAN or WAN is just a bunch of local area network connections that are combined. So a LAN is what you've got in your home. A WAN, or wide area network, is the connection of all of those home networks. It's just one level up. An easy way to think of it is kind of like a game of telephone. Your local area, or a game of telephone being played in an entire school, is probably better. All of your actual, classroom, whatever you're in, is kind of like your local area connection, but the wide area connection would be the whole school. So continuing our school analogy, we're going to talk about 3 more pieces of equipment that you need to set up your home network. There's the modem, which is the bridge between your home network and your ISP's network. So that connection between your local area network and the wide area network. Then we have routers, which connect devices in your home together. And then we have the modem, or 2-in-1 router. The modem router 2-in-1. Basically, it's a device that acts as both a modem and a router all in one. So they're the two separate devices in one package. Continuing with our school analogy, the router is like each of the student's hall pass. It tells the student when it can leave the classroom and when it can talk to other classes. So it's the, kind of like the hall pass. The modem is like a hall monitor. So even though, student walking might have the hall pass, the router telling it where to go, the modem tells it, okay, well, you can only go to this classroom and that classroom with that pass. So it kind of acts as a monitor, kind of enforcing the rules, and tells each student how to act in the halls. They also have the 2-in-1 modem router, which is kind of having it all at once. It's like the hall pass being a walkie-talkie, basically. So that's just the easiest way I found to communicate it. But there are a lot of other analogies that we could use. One other thing I want to mention is something that people have been using a lot more frequently, which are Wi-Fi boosters and repeaters. Boosters are kind of the last piece of home hardware you might have. A lot of times they look kind of like what I'm displaying up above there on the slide. They just kind of plug into your wall. The one on the left is a European model, and the one on the right is the one I'd recommend, the TP-Link Wi-Fi repeater. And I'll have links to those here at the end of the presentation, don't worry. Basically, all they do is they listen for the signal that your router sends out and copy it and send it on further. So as long as it can detect your Wi-Fi, it'll copy that signal and extend it to give your Wi-Fi, a bit of a boost. It's helpful if you have a lot of like metal wiring or thick walls because it can improve the strength of the signal being sent to multiple rooms, and it can extend the range of your routing, obviously. Because of that, it's useful, but it might not necessarily work in all applications. The easiest way around a connection problem is to just get a really long wire. That would be a Cat6 or a Cat5 cable, which I will also show you here in a moment. Hopefully with all of that rambling, you kind of get there's a difference between what the internet is and what Wi-Fi is. Wi-Fi is what you'd be setting up in your home. It's a wireless local area connection. So it's just all of those devices in your home talking to each other. They communicate with radio waves instead of with cat cables or wires. And you can think of it as kind of like your local setup. The internet is a connection of those. It's a big, big connection of wide area connections. And it's only really considered as a whole by ISPs or researchers. The internet, when we say it, we really just mean a Wi-Fi network. But the internet is something that's very different than that. The internet as a whole could be used to refer as to like subterranean connections or sub-ocean connections, things connecting cities and states and countries, or connecting data sending across oceans. So there is a difference. That being said, a lot of people use just Wi-Fi, but there are some limits that you might want to know about for Wi-Fi. First off is that it's a trade-off using Wi-Fi versus a cable. And that trade-off is typically speed. The average transfer speed using a wireless connection versus a wired one is typically about 30 to 60% of what's advertised. So if you have a Wi-Fi, connection saying you could get up to like 600 megabits per second on the connection, let's say. Realistically, you're only probably going to get 300 to 400 on that over Wi-Fi. And the reasoning for that is just the connection speed and data loss on the connection. What's actually happening when you're on the internet is that your computer is sending a lot of data. That data is measured in bits to your cable router. Then your router is talking to your modem, and then it's going, all the way through those steps and changes. The problem is the transfer rate using radio signals is not 100% efficient. So you have to end up repeating yourself. It's like playing a game of telephone when there's a static involved. When you can sort of barely hear the person on the other line, you get most of what they're saying, but not all. That data loss is what accounts for some of those speed differences. And it's why using Wi-Fi, you send the same message a few different times in order to make sure it's all put together right on the other end. But that's kind of the limit in speed. A wired connection rate, on the other hand, is constant and is always going to hopefully be what you're paying for your ISP. There are a few different things that contribute to this speed difference and the loss of information. Most of it is caused by atmospheric interference. So, the air isn't just empty, that's space. There's all sorts of, particles and, atoms and things in the air that we don't see but still exist, oxygen, nitrogen, a whole lot of other stuff. That stuff can interfere with the signal that's being sent, and that causes data loss. Another big issue is walls. A lot of modern homes have a lot of wiring in their walls, and that metal tends to act kind of like a Faraday cage. So it blocks radio signals. Because of that, radio signals being blocked, it causes, the signal strength to drop, and you're not sending as much data consistently, which cause speed issues. Additionally, the distance between you and the signal source or your router is another problem, and that's something that a lot of people have issues with too. A lot of people set up their router in the basement, which is fine, but if it's not like in the center of your basement and it's maybe off to the corner of a wall, that tends to be how you get, oh, this half of the house has really good Wi-Fi, that other half of the house really doesn't. So distance can cause a lot of problems. And lastly is the number of relays in the network. Those Wi-Fi boosters are great if you really can't establish a connection somewhere in your house, but they also add a chain in that game of telephone. So instead of just you talking to the router, it's you talking to someone else talking to the router. That could be another cause of data loss, and because there's another relay in the middle, that adds delay to your speed. So even if you do have a connection, that doesn't necessarily mean it'll be as fast as if you were just connected straight to your Wi-Fi. So all of that being said, I know it sounds a lot more complicated than it actually is, I promise. Why would you want to set up your own connection? There are all these terms. It seems a little crazy. And, why would you want to do it? Well, first off, you're probably not using good equipment if you're renting. The reason is almost everyone rents their equipment from their ISP. Why would I want to go out and actually buy equipment when I can just rent it, no hassle, and have someone else install it? And that is a fair point if you don't know how easy this stuff actually is to set up. Also, modem and routers can cost, quite a bit of money. A modem and router combined can cost somewhere between $150 to $200 if you're using generic internet speeds. That's just the cost of the equipment involved. People think, well, why would I spend that much money at once? And my answer is because you're already spending more than that over a period of 2 years, and you're not getting much freedom. First off, Alta Fiber charges you $10 a month just to rent your router and modem. That can total up to $120 a year. And when the cost of the modem and router is about $150 to $200, you can see that just after 2 years, those savings are already making sense. And most people who have been customers of Cincinnati Bell or Spectrum have been their customer for over 2 years. So they're already easily making up the cost of those routers on you. And it's probably better to set it up yourself and save that monthly fee. Spectrum is a little bit lower. They charge $5 a month to rent the modem router 2-in-1s, and it is about $60 a year. So you're only $20 under the cost of the router itself anyway at that point. So at the very worst, I would just buy the router if you're part of Spectrum. One little sneaky thing that people tend to do, the modem is already included as a rental in Spectrum service. The router is not. They add an extra, like that $5 charge. That's really just for the router. So if you say, well, all I really want is the modem, give me a modem, I have my own router, then you can set up your own router on their network and you can avoid that $5 fee. You might have to call them about it and remind them to remove it from your bill, but you can get away with it, and you'd only need to buy a router if you're on Spectrum's network to avoid that $5 fee. But you gain a little bit more by owning your own equipment. then just that cost savings. You can also take that equipment with you if you change your internet service provider. I know that mine at home and the ones that I'm showing you will only work on Spectrum's network, but there are a lot of ones that work on Spectrum's network and Cincinnati Bell's network and a few other different networks. So one of the big areas where all of those are transferable is fiber. So if you have a fiber connection, then you might want to buy your own equipment just in case a new fiber provider comes into your area and they have less fees. So by owning your own equipment, you can jump back and forth between all the networks, not have to return anything. Another thing you avoid are those late return fees on your equipment. My girlfriend and I just went through this where we had to return her Cincinnati Bell equipment. Otherwise, she was going to face a $150 fine because we're using my equipment now on my connection. Because of that, we ended up kind of scrambling at the last minute and had to return it like the last day, or we would have had to pay that fine. So by owning your own equipment, you can save money on that too. Also, you're getting good equipment rated for the speed that you're actually using it for. A lot of Spectrum people have had to deal with this in the past where they've upgraded their connection speed. No one came out to change their equipment, and they were actually getting about 200 megabits per second to 400 megabits per second under what they were paying for because the equipment they were using wasn't rated for the speed that they purchased. We'll get a little more into the technicalities of that here after this next slide, but just something to keep in mind, that equipment, knowing that it's rated well for the network you're on, just owning your own is far easier. And also, you're able to change network settings directly. That's how people say, make, for my home network, I call it Tom's Net. It's how they change the name of the network they're connecting to. Or like if you're ever in a Best Buy and they say, oh, use our internet, it'll be like saying Best Buy Network, or if you go to Starbucks and see it called Starbucks Wi-Fi, that's kind of how they change it. They own their own equipment. So after all of that spiel, all of that stuff, it's probably sounds kind of complicated to set up your own, LAN connection, and you would be very wrong. You only need a few different things. First, a router and a modem, or you need a 2-in-1 device that does both. A Cat6 or Cat5e cable, which I'm going to show you right here, is one of these connectors. It looks a little like a phone cable, but kind of bigger. You also need a coaxial or digital cable if you're using a digital connection or a cable connection for your modem. You might also need a phone jack connection or an RG6 cable or DSL cable. Those two things will depend on what type of internet you buy, and we're also going to get into that in a moment. And lastly, you're going to need the instructions that come with your router. Those are always in the box every time you buy one. So that one's the easiest piece. So all you need are essentially 2 to 3 cables and your modem and router or 2-in-1 device. That's it. Now, how about a practical demonstration of what's actually going on when you set up one of these? Because a lot of people I know get a little weirded out by setting things up themselves. They worry that they can mess with a lot and break things, and that's actually not necessarily true. It's a lot easier than you think to set this up, and I want to show you directly how you can do that. So let's go ahead and stop sharing the screen. That should make me pop up a little bigger, hopefully for all of you, while we're going through this. And we will need a few pieces of equipment. First, you're going to need a modem. This is one of the sample modems that I keep, and this is a cable-based modem. I can tell because of this cable connection back here. Not all modems, however, have this cable connection. There's also a little port here. But all cable modems will look kind of like this. There will be cable out, and there will be a little wire, connection here, and that's where our, coaxial cable goes. We just plug that in here. There is one other port here, but that is for power, and the power cable I actually lost to this modem. That would be this one. We do have a question, and that is, Is this the Tech Tuesday? Is it time to upgrade to Windows 11? No, it actually is not the upgrade to Windows 11 Tech Tuesday. We did kind of cover that already this year. That would have been, I believe, 2 webinars ago, and you can find it in our webinar library. I'll be posting it at the end of this presentation. Good question. Then you'll also need one other piece of equipment, your router. If you have a 2-in-1, then you can tell because it has all of these connections. Typically, there will be one that's a different color or that's labeled differently. And that's this blue connection right in here. That is where you plug in your cable, just like this one, into that blue spot. So here's what the back of both of them look like. Then you obviously have all of these external connections here. This is where you would take another one of these CAT cables, plug it into your computer, or if you're trying to use the Wi-Fi, you're basically done. You just plug in the power port here, turn both devices on, and you're done. That's all that really goes into Wi-Fi setup from a physical standpoint, and I don't understand why people actually charge for installation of this stuff. It's really nothing. A lot of times Spectrum will actually try to save money by shipping out self-install kits. So you're still renting their equipment, you just still have to set it up yourself, and then they'll charge you for self-setup. So it's kind of pointless anyway. The other type of equipment you might see is something like this. Now, this is a old Cincinnati Bell piece of equipment that they gave us actually when we disconnected everything. They said just keep this one. It's really old. We had upgraded our service, and they just didn't want it back. So I got this. But this is a DSL 2-in-1 modem router, and as you can see, there's a slightly different port on the back up here. That is a phone line connection, and it's what's used for dial-up. A lot of older people tend to recognize this over the other one that I was talking about. There's these 2 cable connections, and most DSL lines you won't have both. You'll just need to plug in one, in which case you always plug it into the DSL labeled 1 slot, and this is just that DSL line connection. So it looks kind of like the Cat 6 cable or Cat 5 cable, but it's just smaller. Then we also have the WAN connector over here. That's in case they were using a router out or a different router, they could connect it here. And then we have the Ethernet ports for actually connecting to your computers. So, very similar stuff. You just plug them in where they should. The other end of this one would plug into the wall. Same thing with the cable modem, actually. You just plug into the cable jack on your wall, and that would be it. So that's really all that setting this stuff up is. Once you're all plugged in, you should be able to get it working. The last step, once you have all of this set up, and I'm going to start sharing the screen again. Here we are. The last step is to call your ISP, and this is why I say you might want to have your actual instruction manual ready, because it'll give you the device IDs that you need for your device and how to get that all connected. What your ISP needs when getting all of this stuff set up is the WAN and MAC ID of your modem. That's printed on the manual for your modem, but also handy, it's on this label here at the bottom of most modems. It has area labeled S-N, and that's the serial number of your modem. A lot of times they make that the WAN ID. But there is also the MAC ID, and that is printed at the bottom of my modem right up here. Now, I'm fine to show you these because I'm not a hacker, and even if a hacker was connected to this network, this clearly isn't an active device, so I'm okay to show it. But these are device IDs used by your internet service provider to identify that this is you and you are connected to their network. So it's what actually gives you service. Normally, you just call them up. I have numbers that I'm going to be putting here in the chat as well for Cincinnati Bell's self-setup and for Spectrum self-setup. If you're on Cincinnati Bell's network, once you buy your equipment and get it all set up, you just call them, give them the ID, they'll change it over. Their number is 513-565-2210, and they actually tried to hide this on the website. It took me a while to find. I had to research for like 30 minutes to find it. Yeah, Cincinnati Bell actively discourages self-ownership because it gets around that fee, and they're also trying to invest in their network. So they're trying to get a bunch of people to, not do this, but I don't see a reason why they would. Then there's Spectrum, which actually actively encourages self-device ownership. The reason being they have less liability on them if their connection doesn't match up to the speed you bought. Their connection number is 877-309-5869. There we are. So that's the number you'd call. Whoop, there we are. Sorry, knocking over some devices here. But that would be the number you'd call for Spectrum activation. Once you call, give them the number, it should connect automatically, and they probably won't send you away or disconnect the line until they confirm with you that your internet is working. Now, the way you do this is by connecting to the router, but you can do that before you even activate your modem. So as long as you're connected to the router, you can see that you have internet going on your device, you're fine. And once you give them those numbers, you're done. So I always tell people to read off these numbers, but one thing they always ask is, what do they mean? First off is the WAN ID. The WAN ID, otherwise known as that MAC ID, or not MAC ID, I'm sorry, the serial number in most cases, is the modem's name on the ISP's network. So a lot of people will change the name of their router's connection. That's how they rename their own stuff. But that ID is how your modem is identified within Spectrum or within Cincinnati Bell's network. It's how they know, okay, this is what device this is, and this is like Tom's account. So that's just how they know that they're not, providing internet to someone incorrectly. And it's also what makes that connection possible. Then there's the MAC ID, or Media Access Control Address, and it's a name used by your router to identify itself within a local area network. That would be the MAC ID, Media Access Control ID. So it's what's used on the local area network to identify devices. Then there's the IP address, and every device has this. An IP address, and this is just in case a hacker tells you, oh, I've got your IP address. All that is the name of your device. So that doesn't really matter much. Oftentimes a hacker will say, oh, I have your IP, and they've just been listening in to what's going on your network. Doesn't mean they have full control or anything. So don't be weirded out. It's just a name. And the last thing you'll have to do after obviously getting ready and going all in on this is actually finding a modem and router that works for you. And there are a few things you might want to know for this. So I'm just listing them here. First off, how much data speed can the hardware handle, and how much speed do you have from your provider? Before you even start looking for devices, you'll want to know this. And the way you can find out actually is by looking at your bill. Typically from Spectrum, at least, they'll say, oh, this is your premier package or the extreme package for internet. That tells you nothing, it means nothing, it's pointless. What you actually want is to find out what speed in megabits per second your internet provider is giving you. And you can Google just, X package on this, what's the speed? And it'll typically be the second or first link that pops up. It'll be a page from either Spectrum or Cincinnati Bell listing out what actually the speeds on their network for each plan are. Now, like we said before, if you're using a cable connection, you should almost always hit that speed. And when you're looking for hardware, you want to get hardware that's at least 200 megabits per second like rated for a network that's 200 megabits per second faster than what you're actually buying. The reason is that can actually get you better speeds. We only buy about 400 megabits per second from Spectrum for my home network, but I've measured speeds of up to 450 to even 500 megabits per second, even though I'm only paying for 4. And a lot of the reason for that is because my equipment's rated to handle much higher speed. Spectrum tends to just give you the speed that you can take, even if you pay for less. So I always get, 50 megabits per second faster to, 100 megabits per second faster than I'm actually paying for, because the network speed can be variable and they just kind of give me as much as I can handle. So, I get a few extra megabits per second. I see nothing wrong with that. Another thing that you might want to know about is the limits to the bandwidth of your connection. That's how many different things can be connected at once and how many things can be going at once using this device. That would be measured in megabits per second as well. And there is a few things to note. Megabits per second, or M capital lowercase b PS, is different from capital M capital B PS. That's megabytes per minute. And that is very different. The main difference is the amount of information that's actually being exchanged. Megabytes is what we use to determine file sizes. Megabits is what we use for connection speeds. So if someone is talking to you about internet speed and they say megabytes per second on their connection, then you know they're probably wrong, or they're actually a computer scientist who knows what they're talking about, but chances of that are really low. One other thing to note is that high speed means nothing. Legally defined, high speed is considered any connection over 100 megabits per second. That is strong enough to support internet streaming with lag in standard definition. And that is what is considered high speed by the industry. So anything over that, they mark it as high speed. And 100 megabits per second is about the maximum speed that is typically carried over dial-up connections. So anything that isn't dial-up is typically high speed, and that's how people get away with marketing packages as high speed that really aren't high speed anymore. Realistically, for home internet, I recommend at least 200 to 300 megabits per second. 400 is about what you'd want if you're pretty intense with your internet use, meaning streaming to 3 or 4 different devices all at once. You want more than that if you're actively doing things online. This is stuff like gaming is just the example I always go to. But another idea is, maybe you're working from home and you're constantly sending data across a network. Well, your daughter is, listening to YouTube, and you've got a bunch of stuff going on in the house. That's when I'd look into larger packages, typically around 600 megabits per second. If you really, really, really hate delay and lag on videos or anything else you're doing, and you want to make sure that you're the one that's got a good connection, another idea is if you're like hosting a lot of webinars, or if you're the one who's actually maintaining a lot of other connections, you're going to want even more than that. And that gets into gigabit speed. Gigabit is the sort of latest advance in internet connectivity. It is 1,000 megabits per second. And if you see a gigabit connection, typically you're talking like Google Fiber. That would be really, really good. It's fairly expensive, but if you can get it, I highly recommend it if you're doing a lot online. So that being said, let's get more into what these devices would look like to you. The first one I want to talk about is routers. Routers being things like this that I had up earlier. A good router will show you all of the information that I've got on screen. This is the Nighthawk Smart Wi-Fi Router series. And smart routers versus non-smart routers, really there isn't much of a difference. The main difference is smart routers can be controlled through an app. So instead of doing what I'll show you later on to adjust your network settings, you can just open the app for the router, it'll connect with Bluetooth, and then you can just change your settings that way. That's really all it is. There's not much more to it. It'll show you up top Wi-Fi speed, and I'm gonna mark up this slide a little bit. This Wi-Fi speed is going to be measured in megabits per second, right here, as I said, can go up to 1750. And this right here is the modulation on the alternating current, or the radio wave that is being used to communicate. The higher the number of the radio wave, the more piercing it'll have through your walls, but also the less range it tends to have. So the higher, AC numbers typically mean you get less range. The weird thing is, though, they also tend to increase the boosters on these to make them have higher ranges. So without any booster, this AC 1900 would normally have less, but they've beefed it up so it has a larger Wi-Fi coverage. And you're also spending more per router as you get higher and higher up these tiers. So as you go up, these will cost more. So just something to consider. A lot of times the megabits per second will also be determined by this AC number. That's why the AC 1900 adds up to 1900 megabits per second possible transfer speed. That just means it's possibly sending 1 bit per second per carrier wave, which makes a lot of sense if you're technical, but if not, it just means higher number, more data being transferred at once. That's the rule of thumb. The coverage here tells you about the range of the Wi-Fi network. Obviously, the wider the range, the better coverage you'll get over a wider area. The trick about this is that the higher the range, the less effective your connection will be over that range. So if you're 1,500 square feet away from your router, I don't think you're going to have much of a good connection. But if you're only 1,000 feet away, you might have some. And then if you're only 500 feet away, you're probably fine with this lower router, the R6700. Then it also has the recommended number of devices. And this is kind of an interpretive manner for showing what the way that, information's routed around this router or, your device. Basically, it's telling you about how many devices you can have connected without the whole thing crashing. This one crashes at 25. The next one up crashes at 30 devices. The next one after that is at 35. Unless you intend to have a lot of different things connected all at once, I'd probably go with the lower end one right here in this case. Then it also tells you the number of Ethernet ports. On all of these models, there are 4 ports that communicate at 1 gigabit per second. And that is actually really good. The trick is you want the higher number of these if you've got a lot of devices, a lower number if you've got less. The more complex the network is, the greater it is for a lot of devices, the worse it is for a single one. So having only 4 of these connections make it perfect for home use. 1 gigabit is probably the speed you'll want as well. Even though our network might be lower, like the actual speed we're getting, you want the highest rating that you can because that means those devices can hypothetically talk faster, giving you faster internet speed. It'll also talk about USB ports if it's a smart router. The reason being a smart router can actually talk to wireless printers and things directly as well. A normal router can do this, but it probably won't just tell you how to do it. So that's another difference between smart routers and normal routers and something to consider. But USB ports, I don't really care about them in my router. You shouldn't feel like you need one. And it also lets you interact more directly with your router. So it's a nice feature, not one that most people would typically use. It goes into parental controls because it's a smart router as well. This is you can figure out which connection is your kid's device and say, okay, they can only access kids networks, kids, YouTube for kids, that kind of stuff. So that's something else that you can do here with parental controls. It'll also talk about network security. As long as it has a firewall, it should be fine. This WPA2 is kind of industry standard, and it should be a fine firewall. It's not something you should typically consider because most of the time that's kind of at the device level, but it's a nice thing that this router has. Most routers nowadays actually do have firewalls, even if they're not smart routers. So good that it has it, standard. Then there's also the Netgear armor protection. That's like additional like kind of protection insurance for your, cybersecurity, don't even worry about it. It's not something you should consider. It also talks about kind of the technology that they use to send out information that doesn't really matter, and some additional features. When I say it doesn't matter, I mean it shouldn't matter to a consumer directly for home use. For doing more advanced things, you might want to look into that, but it's not something we need to look at. The real things we want to see are Wi-Fi speed, Wi-Fi coverage, number of devices, and ports. Those are the things that you really want to compare when you're going back and forth here. And really, it's just make sure you get a speed for your router that is not lower than your actual internet speed that you're paying for. So the next piece of equipment you might need is a modem. This would be the just pure modem that I'm showing you. And there are a few things you want to look at for this as well, although this is much more, bare bones. First is you want to see what speed it's rated for. Like I said, you want to go about 200 megabits per second above what you're paying for. For me, I actually use the Surfboard. This is the modem that I use. I use the SB 6190. And as you can see right here, it's up to 600 megabits per second. My home connection only has 400 megabits per second, but because my modem is rated for a higher amount, I tend to get that higher amount anyway. So just a little thing to consider when you're buying. Additionally, it has downstream and upstream channels, and that's something else you want to look at. That tells you how many different channels it has to communicate information, and the more the better. 32 by 8 is what I would recommend as a minimum nowadays for getting a modem. You can do it with less, and that's why that 400 megabit per second modem exists. My guess would be, and this is just a guess, please don't quote me on this, my bet would be if you added the additional channels to this one, it would probably have mostly the exact same equipment as the other. And it's really just limited by the number of channels that are on the board. Then there's DOCSIS 3.1 advanced technology. That's just the additional, sort of protocol in place to talk on this modem. And it is only used on gigabit networks, which is why the gigabit one has it. And there's also gigabit Ethernet ports here. This is the basic modem, and this is actually the 61. This is the 6121. So this is the modem when it was put out by Motorola. And that's just saying it has this one out to connect to a router, which is this piece. Another rule of thumb, if you're not sure what device you're looking at, a router has antenna to talk to other things. A modem likely won't. And a 2-in-1 will likely have an antenna and all of the modem connections we mentioned. Now, speaking of 2-in-1s, here's what something for a 2-in-1 will look like. We not only have the cable internet speed plan listed here, which is the first thing you want to look at. That's the modem bit, telling you what sort of connection it can support from your ISP. It also will give you the downstream and upstream channels and the Wi-Fi speed with the current. So this one probably communicates at 1,600 megabits per second, this 1,009, this one 2,350, so on and so forth, just based on the AC number. Then it tells you how many gigabit ports it has. These are the ports going out to talk to other devices on your local area network. So this would be the maximum number of wired connections you've got. Listed right here. Then we've got the USB ports that we mentioned before, Quick Connect via App Manager. That just means it's a smart modem. And it also includes tech support, I guess. So if you called Aris directly, they would help you with this device as well. But that's sort of what those numbers mean and what you should look for based on your connection speed. One last thing you can do once you're all set up and you've got your network working is you can actually edit your network settings. This is what I was getting at before with how Starbucks networks can be called Starbucks network and so on and so forth. In order to get to this, you need your router's IP address, and typically that'll be listed in the manual for your router. On my Eris router right here, it actually has the default wireless password and the serial number listed here, as well as where to go to get access. I don't know if you'll be able to see it. It's right by my middle finger, right here, but it has a website on the bottom here. And most of the time, it'll kind of tell you where to go to edit your network settings on the bottom of the router or as part of your IP address. Now, finding your IP address, unless you're, like me and have it on the bottom of this router, it's normally not printed. Where you go with that would be your computer's network settings. But basically what you'll do is you'll type that address into your web browser on a computer or in your phone. And then once you get there, you input your network's, password, the default one. Default one for this one is just admin. Most of the time, that's what it is. And once you get in, you can change the password and name for your router, which also changes the password and name for your network. You should only do this to personal equipment, though. If you are renting, you should not do this because a lot of times with Spectrum, when you return their rented equipment, they have to reset it, which is literally as simple as pressing a button. They will charge you for it. So that's something you only really want to do if you're on your own network. There are a few different ways to find your IP or how to access this. Default access for the TP-Link series, which is what I was showing, is printed on the bottom. But if you don't know where this is, you can also just go straight to the IP address for your router and it'll work all the same. That is listed under settings. So in Windows 10, we would go to Windows Settings, Network and Internet, which is shown right here. And then under that, we would go to Status, Change Connection Properties. And then we're looking for the IPv4 address of your router. You'll then go to your internet browser, copy and paste that number into your web browser and hit enter, and then enter the default username and password for admin access, and there you are. From there, you can change all of the network settings you please on your router and make things like, go to our last slide, this on people's phone screens, where this LAN is your LAN, this LAN is my LAN. Those are two separate Wi-Fi connections that have been edited. So that's basically all it takes to set up your own home internet connection. It's a pretty straightforward process, but a lot of people just get confused by it being overly technical when all you really got to do is plug three things together and put something in the wall. If you have any additional questions at this time, I'm happy to answer them. But if you also want to reach out to me directly and have a separate question, you can do so. My phone number is 513-487-5390, and my email address is tlevine@crnstone.com. Additionally, before I get into some user questions, please go ahead and type them out. I want to send a few links into the chat as well. First off, we are going to be sending some of the links to some of the products that I had up. First is a link to the Wi-Fi repeaters that I showed. The first one with the European plug is going in first, but that one was kind of iffy. It was like 50-50 on reviews saying it worked perfectly or it didn't work, so I found a backup one. This is the TP-Link router, which is actually the #1 rated on Amazon. That's that second link. Then we also have the Netgear Smart Router. This was the router that I showed in my example, and this is actually the lowest tier link. That one is there at the bottom, and I'm going to label the rest of these as I go through. Here is the link for the modem that I was talking about during this presentation. And here is a 2-in-1 link that I had for the 2-in-1 that I was showing. Just give me 1 second to finish typing it out. Sorry, it's a pretty long link and I had to go all the way back to the top. All right. And then there were a few other ones I wanted to link for you as well. If you're curious about AGB and our launch of that, you can find more information about it here at www.crnstone.com/AGB. Additionally, if you are curious about watching a former webinar, this would be the previous webinars on Windows 7, modern computers, things of that nature. That would be there at our webinar series link. So that is all of the links that I had, and I hope you had a wonderful Tech Tuesday. Thank you so much, and I will stay around for a few other questions. Thank you.